The deposit data management system, which is used to store data in the LAP control application, can also store data in a PostgreSQL database. In order to use this function, we need to first create a database on our Postgres server. So let's say we create a LAP data database. I've already created an LAP user here. Save. And now we need to connect to this database. So let's start the LAP software. We could also do this with just the deposit the graphical front end. And in the Select Data Source dialog, switch to the PostgreSQL tab. Type in the host and port. So the host right now it's on my local computer, so it will be the local host, but I could just use a remote host here to connect to a remote database. Localhost. The database would be LAP data schema public. That can be my default username, LAP user, typing the password. And I have to select an identifier so that this can be again LAP data. So I can, in the same database, I can store multiple deposit databases. So then I can use a different identifier for each of them. Now, since I typed in everything correctly, I can create the database, and I am asked to select a local folder because every deposit database also stores any photographs or additional files on the hard drive. So I need to select a folder where this will take place. Again, this folder could be on a shared folder somewhere in the network. Right now I will just save it locally, select the folder, and the database is created. I can use it just as I would use a file database. Now, to demonstrate some specific properties of a PostgreSQL database, let's open it in the deposit interface and import some sample data from a file database. Okay, the first thing we can see that all the files that were previously in the file database or associated with the file database have been imported here into the local folder that I have specified when creating the database. So these are just the SVG drawings generated by the LAP application. But there is no file, of course, with the database, since the database is now stored on the PostgreSQL server. But if I have selected to backup the database after every save, so every time I make some change in the database and save it, a backup is created here in a backup folder, which is a pickle format file database, which I could open in the normal way. So and such a backup is created every time the database is saved. So you can, if anything goes wrong, you can just return to a previous version of the database. So let's have a look at the structure. In the standard deposit format, the PostgreSQL database, the tables look like this. So there is always first the database name or the identifier, then there is a table containing the classes, and so each class has some parameters. So even though this is in legible text, so it's in a regular, it's in JSON format, but it's not so useful to interconnect, let's say, or to use this data in other software. This is a specific format for deposit. But it's also possible to store the data in a more standard relational format. So if I go here on data, save as PostgreSQL, and I select PostgreSQL relational. So again, I fill in the connection details here, and okay, I have to first create a database here in the Postgres admin interface. So this will be a database called LAP relational owner. So LAP user, save. Okay, so LAP relational username, password, and the identifier can be again LAP relational. Let's click on create, and I have to select a local folder again. So let's create a new folder where the data will be stored. Now I can choose to load it immediately. The database from the deposit point of view looks the same, but in Postgres, if we look at the tables that have been created, this is now a more standardized SQL format. So each class is represented by a table. So this is the class sample, and each descriptor is a column. So it's a similar view if you look at it here in Postgres as you would see in the deposit interface when you just open the tables. Also the values are represented either as text or as numbers, just the normal format. The geometry data is a bit more specific. I'm able to scroll to it. So it's a JSON format where the type is specified, and then the value has a WKT, well-known text formatted string containing the coordinates of the polygon. So you can just read this field as a JSON value, then just get the value from it, and then work with the polygon data. And also any links between classes. So the relations between classes are here stored as foreign key tables. Okay, this one doesn't have any keys, but let's say, for example, there are an arc. So the links between the samples and the arcs that we have captured when measuring the diameter would be here. So this is a normal way. So you can work with this database as you would with a normal relational SQL, PostgreSQL database.